Hello, my name is Subhendu and this is my presentation for BRSM mini project. In this project, I analyzed how real-world sounds influence the perception of ambiguous visual objects using experimental data. This report provides insight into multisensory integration, how our brain processes and combines auditory and visual information. The experiment consists of two phases: a visual discrimination phase where participants view an ambiguous object morph and hear a sound while trying to identify the object. A continuous report phase where participants adjust their responses to match what they saw. The key manipulation in the experiment was the timing of the sound. In experiment 1, sounds were played before and during visual discrimination. In experiment 2, sounds were played after visual discrimination to test whether effects were perceptual or decisional. The dataset contained detailed trial level data including reaction time, report error and sound conditions. Using these datasets, we explore learning effects, auditory influences on perception and speed accuracy trade-offs. Research questions. Is there a learning effect across trials? To analyze whether participants improve over time, we examined reaction time and report error across trials. The RT graph shows a slight downward trend, indicating that participants became faster over trials, suggesting a learning effect. However, the report error graph does not show a clear trend, meaning that accuracy did not necessarily improve over time. This implies that participants responded faster with practice, but the accuracy remained stable. Second question. Does auditory context improve performance equally across different types of ambiguous visual stimuli? We analyzed whether different sounds affect perception differently. The first graph shows that certain sound caused a greater shift in reported morphs, meaning that auditory context does not affect all stimuli equally. The second graph in experiment 2 shows that when sounds played after visual discrimination, their influence on reported morphs is significantly reduced. This confirms that auditory effects occur during perception, not during post-perceptual decision making. Third question. Do specific sound pairs, example hammer seal versus cat kettle, show stronger or weaker effects on congruency on RT and error? The violin plot shows hammer and train sounds cause more variability in report error, meaning they have stronger auditory influences. The box plot further confirms that certain object pairs like hammer seal show more variation in report error compared to cat kettle. This suggests that some object pairs are more ambiguous or more affected by auditory congruency than others. Fourth question. Is there a speed accuracy trade-off? To examine if participants sacrifice accuracy for speed, we analyze reaction time and report error. The scatter plot shows no relationship between reaction time and report error. This suggests that participants did not necessarily make more mistakes when responding faster. There was no strong speed accuracy trade-off. Fifth question. Does the variability of report error depend on type of sound played? We analyzed whether certain sounds led to more inconsistent responses. The violin plot shows that sounds like hammer and train cause wider distribution of report error, meaning participants were less consistent in their responses for these sounds. This suggests that some sounds exert a more stronger auditory bias, making it harder for participants to consistently identify visual morphs. Sixth question. Do participants take longer to respond in trials with higher report error? We tested whether participants were slower on trials where they made larger mistakes. The scatter plot shows no clear trend between reaction time and report error, meaning that trials with higher errors were not necessarily slower. This suggests that participants' confidence or decision-making time did not strongly affect their accuracy. In summary, this analysis confirmed that auditory context significantly influences visual perception. Thank you. In summary, this analysis confirms that auditory context significantly influences visual perception, but the effects depend on the timing of the sound and the specific sound object played. Participants improved in reaction time but not necessarily in accuracy over trials. Auditory effects were strongest when the sound played before or during visual perception, and they disappeared when the sound played after. Some object pairs, example hammer seal, were more affected by auditory congruency than others. There was no speed accuracy trade-off, and error variability depended on the type of sound played. This study highlights the importance of multisensory integration in object perception, reinforcing the idea that what we see here influences what we see. Thank you.